Hey everybody, my name is Lester Martin. I am a developer advocate over at Starburst. I like to think of myself as not just a Starburst DevRel, but a Trino DevRel, and even just the whole data engineering space, including cool topics like Apache Iceberg. So what I put together, and I'll share it in the comments of the video, is a tutorial, a hands-on walkthrough of some of the exciting features that have surfaced in Iceberg v3. And I want to make this recording not a big slideshow, but a big hands-on stuff, and give you a quick reference should you choose to do these hands-on labs. You have somewhere to go back and look. If you get stuck for some reason, there'll always be a report a mistake in the lower corner that you can click on, and it'll reach me ultimately. And without further ado, let's jump on in. Let's talk about it. So Iceberg v3, I'm making some assumptions that, if you're listening to this video, you know a little bit already about Apache Iceberg as a table format, and you've learned that there's actually some cool stuff going on in this specification world, which means, hey, you understand. Usually there's another, there we go, I think I made it too big, table spec. There's a version 3 concepts here. So here's some of the major features that have surfaced in there. And I'm just going to iterate through some of those as we go. In fact, you can kind of look at this bulleted list here. You can kind of look at my items on the left and you kind of get a gist of where we're going with this. But to do the labs, what you need is an environment that has the Iceberg v3 connector in it. Probably the easiest way today is just get set up with Starburst Galaxy. It's a free trial. Oops, wrong link. Starburst Galaxy, a software as a service, fastest way to get run in Trino, so on and so on and so forth. So I encourage you to do that. And what I did do is I provided you some links as I clicked here. If you've never used that, we have some Starburst, some tutorials how to get set up and just dabble around if it's totally net new to you, as well as another tutorial that help you get set up with creating an Amazon S3 writable catalog. You'll need that in this lab. So I've got all that set up as you see over here in this other environment. So generally speaking, I'll just hit the old next button. So to prepare the environment, I need to create a schema. I went ahead and did that. So I have one called Iceberg v3. It has no tables in there right now. And in reality, I just want to make a quick check and make sure that version 3 is something that's capable. So I'm going to do a quick run here. I did a CTAS, create table quick test, make sure it's a version 3 Apache Iceberg table. And then I'll just look at the show create table to make sure that the DDL that the system thinks it's just going to echo back that version 3. Now, of course, I'm using my free, always free server inside of Starburst Galaxy, and I should have hit the button to spin that up because it does take a short little time to spin up, and it does quiet down after about 5 minutes. So my hunch is any second now that's running. It's queued up. It's about to go, and what we'll do is see. Yep, that'll say version 3 and Iceberg. So I'm going to click next because that's going to happen. I'll show it to you there. Let's talk about probably one of the elements that gets the most noise and interest out there. It's called the positional deletes. And it's worth taking a moment and reminding ourselves what happened. Well, there's that table. Okay, Iceberg version 3. All right, so what happens in a table in Iceberg? Let's just set one up and we can see it. Maybe more practice. All right, so there's some data that's out there in the TPCH system generator, the connection. So I'm going to focus in about these 1,500 records. They start with a customer key of 1 to 1,500. So what I'm going to do is I'm going to say, hey, create me a table, and I'm going to do a couple inserts. I'll run a bunch of things at once. How about that? So what's going to happen here, I'm running a table. I'm going to put 500 records in it. Then I'm going to add 500 more, and then I'm going to add 500 more. And then I'm going to ask the Iceberg metadata tables, show me the files that make up this table. And under the covers, way out there in Amazon S3 are 3 Parquet files, and they each have 500 records. That's good. That's what we wanted to do. And they all have spreads, 1 to 500, 501 to 1,000, so on and so on and so forth. So what I like to do is issue a delete statement on every customer key divisible by 5. That's going to be about 300 rows. That makes sense, 1,500, and if I did that, if I go back and look at that files again, what's happening, the way we do deletes in Apache Iceberg is these are immutable files. Or the covers we can't really change them? We could, but that would be building a new one. And there's different strategies like copy on write and a merge on read. So we're using the merge on read strategy. What's happened, if you look really closely, there's 6 files now. There's 3 files, 500 each, and there's 3 more files with 100 each. These are the deletes. These are called delete files. And if you open them up, and you would see that these are positional delete files. They're going to reference 100 records in each one of those, and they're linked back to those files. That's kind of what's happening there. If that's true, what's going to happen though is if I delete some more records, so anything that's left that divides the custom key divides by 2, that's 600 more records. So I'm going to go back and search that files metadata table one more time. And oh my gosh, I'm up to 9 rows. There's the 3 500s down at the bottom of the 3 100s that were deleted, and here's 3 more batches. These are the ones in the middle that I'm kind of highlighting right here. Those are our positional delete files. And I'm just going to make the problem even more fun, and I'm going to delete with what's left, anything divisible by 3. That's about I think it's 100 and 200 more or something like that. Yeah, 200. So one more time, I'll look at that record count, number of files. So I'm going to be up to 12 now. 12. So the original 3, and then I deleted, and I deleted, delete. So what am I doing? I'm building this long trail of deletes. And they're all very small. They have lots of problems. Now, the good news is, we do need to do table maintenance on a regular basis, and this stuff is relatively, easy to fix with things like I just did there, a compaction. And if I look at it again, you're going to see that that's getting cleaned up again. There we go. These are the new 4 files. Everything's new, replaceable. This new snapshot has this. You add that up. That should be representative of the numbers we talked about a little bit earlier. Okay. Of the numbers that are left. Sorry, not the 1500. Sorry, my bad. Okay, so that's the backdrop. Now, what happens is in V3, and I'm going to do the same thing real fast. I'm going to build another table exactly the same setup. Has 3 files, each with about 500 things, and I'm going to do the exact same operations. But what's going to happen is something slightly different. Now, when I first, there we go, 500, 500, 500. When I first delete just a little bit, when I delete my, 300 records, and I look at it, it's gonna look like before. I got 3 files with 500, and then 3 more files with 100. This is what happened last time. What you might notice is this file format says something a little different. The way those positional deletes work, they were actually Parquet files. You could open them up and look at it normal. These are binary deletion vectors. What's in them? Essentially the same thing. Pointers and references of those things. But what's kind of slick about this is we do delete a few more records. Okay, let's delete whatever's still left, divisible by 2. That's about 600 rows. Now, I'm going to run the files again. And what you should notice is instead of now having 9, the first batch and then another batch, is I have more, I still only have 3 of these puffin files, these binary deletion files. And they represent more records. Earlier we had a batch that had 100, and then a batch that had 200 per. This batch has 300. So we're rebuilding basically that delete file, this different kind of delete file, a binary deletion file. And if I do it one more time, and deleting left by 3, which is another 200 records, I think it is, guess what? If I went back and one more time looked at that file, so I'm still only going to have the 6 files, the 3 plus 3 more. Basically, what we're saying is at any given time, these special type, these newer, better versions of these delete files, these binary deletion vector files, these puffin files, are going to be 0 or 1 per every data file, not 0 too many, which you saw before. And because they're getting bigger, all kinds of good things are going to happen. Less files to go I/O, doing gets and that kind of stuff. Fewer, smaller files, all that kind of stuff. And that may or may not seem all that exciting, but it's pretty darn exciting. And like before, when we did do a compaction, we're going to see those get rolled up and flattened back out. And we should be back to about a handful of files. That total, I think it is, about 400 records that still remain. All right, so I think we made it through the positional deletes. Checking my notes. Yeah, nothing else I wanted to show there. What else can we do? Oh, there was the V2 and the V3. So there we go. There's examples, good stuff, good pictures that kind of reference what happened there. All right, what else is going on? Well, Probably another big one that people want to talk about is the variant data type. So let's jump into that. Now, the variant data type, what does that mean? Well, at its limited level, here, we'll just kick a couple rows off here. It allows us to have a new data type. The new data type, if I look in my Trino mappings here, we're going to see that a iceberg type of variant right here is going to map to a Trino internals type of JSON. So basically, generally speaking, we're thinking of variants just to house unstructured data. They can have some other concepts too, but by doing that, now I can, as you see here, I built a column called data. It was that type JSON, and I inserted some things, some key value pairs and that kind of stuff, and I searched it. You see something that looks, pretty normal looking there. Now it's a good time to maybe look at my tutorial over here and say, look, here's the thing. It's not necessarily really JSON like you think of. It's just that that's how our tooling works. That's how we can see it from our interface, and we don't have to change our API, our SQL API, etc. But under the covers, this is being stored in a Parquet file. It is doing the exact same thing as any other engine needs to do, wants to do, and we want to do that to make sure we can not just adapt and change to a flexible schema, but we absolutely want to keep that multi-engine compatibility going. So let's do a little more exciting one than just two little docs that were just a name and a value. Let's create a new table. I'm a pretty avid pen paler, and what I'm going to do here is took a few records, and most of this is real data, so have fun. I'm not necessarily wanting you to stare at this just yet, but I said, hey, add about 4 records. Remember, I'm doing this so you can have easy to produce and get all the data and run this lab yourself. But as you see, I have a table of the name, a status, and then maybe some details. What's going on with this person? Now, it might be easier to kind of glance at again up in the screens here. There we go. There's me. There's Lester. That's my mailing address name. There's my city, state, zips, and that kind of stuff. And if you look really closely, you're going to see different things. When it's in a different country like the Netherlands, maybe there's different values, different definitions, property names. Postal code instead of zip is a great example. There's no state up here like we see in the US of A. And I have other things, an email address that may or may not be there, an array of socials that may itself have their zero or many or one or many, hopefully, ideas, etc. So we can come back and look at the data, but let's kind of look at it a little further. So I want to say this: hey, what would it take, since buried in there was an email? Let's look at it one more time. Email Lester Martin there, and there's my socials, right? Those are kind of top level of inside that variant. So I'm going to look at those. How might I do that in a Trino vernacular? Well, I have a plethora of JSON features and functions. I'm using a certain set. You can use different things to get there, but generally speaking, I'm just saying, hey, give me the email, give me the address, .county. This is a flat out single object, not array just yet. And then I just elevated them up at name and country. Now, if this is a big data set, then I really was just trying to look for folks that actually have an email address and who live in the good old US of A. Then I might want to do something a little bit more arduous. So I just did a common table expression to kind of raise up, elevate those, and then I can more easily just kind of use the classic predicates to look for the things I want. I found Lester. And yes, Joe Schmo is not a real person. All right, if you remember, there were also at the top level some socials, an array of socials available to us. So I'm going to take a look at those. And yeah, hey, look, there we go. This actually it's sisters in Netherlands I email with, mail with, etc. Instagram, post crossing, that kind of good stuff. That's great. But what if I really want to, dig into those a little deeper, and maybe I want to denormalize this a little bit to help me use standard SQL to leverage that. So again, I'm in Trino, so I can start using my Trino E's and my Trino SQL kind of activities. And there we go. I bursted out. What I did this time is broke each one of the elements in the socials into its own record. So you see, repeat, everybody had 2 just to keep it easy for me to visualize here. But I still have this kind of nested object. So if I wanted to break it apart even one more time, why? Because I'm looking to just find folks who have Instagrams I can basically, just continuing to kind of grow that query up a little bit, not trying to focus too hard on it, but extract that out, kind of not just denormalize it, but then unnest it. And then ultimately I just need a couple columns, some names, and some Instagram IDs that I can kind of go look at. Now, the good and the bad news is that looks kind of, it's not that big, it's not that ugly, but in fairness, likely, I might just wrap that same statement with a little view. Why? Because maybe people that just want to get some Instagram users, maybe they can just hit that and say, yeah, those are the folks that I'm talking about, I'm looking for. And you know what? All of a sudden, that's starting to smell like, like a data product, a data set inside of a data product where we start to hide and nest some of the scariness of the SQL, make it easier for folks to start to consume stuff, etc. All right, that gets us over to a couple more. I'm going to focus on just two primary things I want to do here. Really, it's nanosecond timestamps and default column values. So let's just see some of those things. Nanosecond timestamp. Well, today in version 2, for most folks, while you can kind of set up and declare that you want a version 2 Iceberg table to go down to the nanoseconds, you see here I got 0.123456789, and I added that. But when I did a select on it, if you look closely, it might look like it's there, but it's not. 1, 2, 3, 4, 5, 7. So it's actually being rolled up. So this is the microsecond. Yeah, microsecond, 1/1,000,000th of a second. That's what version 2 supports. But we can go even further down to the nanosecond. Should you have a need, you have that level of precision. I just created another table, inserted into the exact same timestamp, and then said, hey, show me that you're tracking all that. There we go. All the way down to the full 9 digits, decimal distance of a second. So whatever that is, 1/100000th of a second. Yeah, whatever it is. I think it's a billionth, right? No, 2. Yeah, if 6 is a billion. Yeah, pretty small measurement. Great for scientific communities, other those kinds of things like that as well. What else do I want to show? I want to show default columns. Absolutely, today is 2000 and let's see here, 2025. And yes, relational databases have had default column values probably since the dawn of time, but this is relatively new to version 3. So you see we have a field called data varchar, and we defaulted it to Bob. So I set that table up, and then I added 2 records, ID 1 of Alice, and then a second record with an ID of 2. And then when I did a query, which I thought I did, I guess I didn't run the query anywhere in there. Interesting. So we'll just type that in here. Select all from default column. There we go. I think that'll get it. We should see those 2 records. Yep, Alice. And then there's our default Bob. You could also add, alter tables, commands, and when you alter it, like such as this, we're adding a column. Could be set a default to this. Sure, it's a date. I added 1 more record, number 3, Charlie, and then it's kind of hard to see with a little. There we go, and there we go. We got a timestamp, and you probably did notice. Yes, we're not backwardly backfilling all existing nulls. That actually would be very expensive. Could you do it? Absolutely. Do an update where birth date is null, set it to the default value, but do realize that is a pretty big change, and just take that into account. Compaction soon thereafter is probably in line, and some rolling off of some snapshot versions be a good one. All right, and then lastly, probably one of the weirdest, interesting, funnest elements of this is this notion of row level lineage. So I haven't been looking at snapshot IDs and that good stuff, but those that have been using Iceberg know we are generating a new version of a table every time we make some changes. If it was 1 record or it was 1,000 or 1,000,000 records, it's still a change. And because of that, we have the ability to do differences between version 7 and version 8, version 9 and version 3. You can kind of check those out. We can roll back, we can do time travel, lots of cool stuff, but we don't have exact row level lineage. If we really want to drill at a particular row, walk it backwards, see how it got here, what happened when it changed, those kinds of things. And those are some foundational things that are showing up. So what's happening under the covers, you're going to see, is that we start to add these kind of additional hidden columns, this row ID and last updated sequence number. And I'm going to show you some details as you get there. But first, let's just see what happens in without this. So here we go. I'm going to do a quick table add. I'm pulling some stuff from the TPCH customer records. And generally speaking, I'm just getting the customer key out, carried for the comment for giggles. And I played with it so that the customer keys would be 100, 101, 102, 103. And I'll show you a little later why that matters. Okay, now what I'm going to do is don't look. Close your eyes. Don't look what I'm doing here. I'm going to make some changes. And yep, 1, 2, 3. There's 1, 2, 3, 4. There's 4 commands right in there. So 4 new snapshots were created. So we could go backwards and try things out. But if we just said, someone else walked up and said, what's going on? They might look at this table of 4 records that a minute ago had customer keys 100 through 103, and now we have 104 to 107, and logic might tell us, let me scroll off the screen what really happened. Logic might tell us that we just simply deleted the old records and added the new records. And I tried to visualize that kind of here. This is what we had a minute ago, and here's what we have. And if I'm just doing a comparison between these two, I might come up with that understanding if I just look at points in times. This old version a few minutes ago and this new version. And okay, not exactly true. But if we did scroll back and let you look at these statements, what's really happening is that let me see if I can put them on the screen at the same time. Yeah, that might make it more fun. Yeah. What really happened is a couple rows were updated. The 101 customer key became 104. So this really is that one. The 104 record, which was at the bottom, became the 105 record. We deleted the 101, the 102s completely. We added 6 and 7. So we did 2 updates, 2 deletes, and 2 adds. But it's just not really crystal clear by the fact we don't have that ability to kind of backtrack it. And yeah, you can do all kinds of fun stuff. I'm suggesting don't try to do this kind of stuff right here, but it's the classic what's different between now and then. And in that world, you may not always know what happened. You just know collectively what happened by having, table level or snapshot level lineage and that kind of stuff. So guess what? Joey put his super suit on and he said, I'm coming to save the day. And let's see what happens when Joey shows up to help us out. Well, all right, got it all going again. All right, so I'm going to build another table. So same setup. Customer IDs 100 through 103, and I'm just going to look at them. Now this time I said don't worry about the description, not all that interesting to look at, but look at the keys again. So customer IDs 100 through 103. And what's happening under the covers is this row ID got created. And it makes a little bit of sense. Row ID is 0, 1, 2, 3, And we see this notion, these all together were made, these happened at sequence number 1. Okay, great, everything happened. Now what's gonna happen, and I'm gonna run these and talk about them and then we'll look at them. Let me just say, do all this. Yeah, we'll run it all, and then so that we can see at the bottom, and then we'll kind of talk about it so you can see it side by side by side. So I'm doing exact same updates as before. I just kind of articulated it a little bit better here. So first thing we did customer ID. Key was 104, but I updated it. I actually said the one that was 100, move it to 104, and it was a row ID 0. Okay, and it was part of sequence number 2. Now, I then did the delete where I deleted the 101s and 102s, and I'm going to delete that, 101, 102, and those are gone now. They actually are part of a sequence number 3, so if we kind of backtrack, you'd see some of those things. And then I did another update, which was the 103 record, which just happened to have row ID number 3, because I made those numbers all line up pretty, and marked it to, as you see there, 105. And then that was sequence number 4. And then sequence number 5 was adding 2 more records, number 106, 107, there they are, 6 and 7, and they're part of sequence 5. So there we go. We're actually getting to see all those fun things, and I think going over here and maybe showing a slightly different incantation of that, it's the exact same data we did before. This time we just have a much more clear visibility. When this record was updated to 104, the 101s, the 102s, those actually were deleted, so they're not really showing up in this current version, but there's that sequence number 3. If you kind of backtracked under the covers back, you would see that. There's number row ID 3 that got updated, and then row ID 6 and 7 also were inserted over here. So this stuff is foundational in nature. Some stuff you can start to plan on yourself doing here, and lots of good stuff for auditing and traceability and stuff. But ultimately, I think a lot of this is going to be let these engines that are using Iceberg up their game and really be a lot more responsive in these incremental dynamic tables, incremental materialized views, all that kind of good stuff of building and creation. And the good news is that was really what I wanted to show you there, so I won't bore you with my teardown. I'm just ripping it all up. I will say, if you're watching this video and you did use the labs mentioned early on here, such as using our catalog, take a good look and remember at the very beginning of this thing it says that, hey, we're going to actually delete that information pretty quick, at the end of the day at the latest. And in fact, the best thing you can do is go ahead and tear down your the entire catalog. So I gave you some instructions if you haven't done that in Starburst Galaxy before. Just disconnect it from any clusters that are using it right there, and then go ahead and delete the catalog. So if you want to do it again, come back from scratch and re-add it. So we're helping you, but we're not giving you unlimited rights and that good stuff. All right, ends up, I'll put, like I said, in the description, I'll put a link to this tutorial. Have fun, learn all about it, play with it. Let me know what other questions, comments, and concerns you have. And I'll see you on the flip side. Thanks now.